This is R.D. Sharma solution, class 12, chapter 10, differentiability. Exercise is 10.1. So before we go ahead, let's talk about what is differentiability. Differentiability, before that we have to know about continuity, because differentiability only comes after continuity. So if a function is differentiable, that means it is continuous. But the inverse is not true, converse is not true. That means if a function is continuous, that doesn't guarantee the function is also differentiable. So if we have a function, we need to check its certain point. Please remember that dy by dx is the differentiability, and we are indeed talking about the rate of change of y with respect to x at that particular instance. That is at that particular point. Because average speed can be computed, constant speed can be computed. What about a particular point? What is the speed? How the y is changing with respect to x? That will be known by the tangent at that point. So if fx is a real valued function, and that is defined in an interval, open interval a comma b. So if we take a point, say any point k or c, and we are interested in finding out whether the function is differentiable at this point c or a k or whichever constant you take. So c is belonging to a comma b. So the fx, the differentiability of fx, that is f dash x, will exist if limit x tends to c, that is the point we are checking. The limit x tends to c, fx minus fc, that is we are checking at the value c, fx minus fc divided by x minus c. This is finite, this exists. It is not of the form of 0 by 0, infinite by infinite, 0 by infinite, or infinite by 0, like that. Then we say that this function is differentiable at point c. So basically we are interested in what? The tangent. So how to find out? In continuity, what did we do? We just go back a bit, we just move front a bit. That is, we go to the left hand limit and the right hand limit and try to find out whether they both are equal or not. That is, there are no two tangent but a single line whose slope is equal to LHL and RHL. Okay, left hand limit and right hand limit. Same way, the left hand derivative and right hand derivative we are going to compute. That means the left hand derivative has to be equal to right hand derivative. That is, we are interested in just one tangent rather than having chords. And that tangent slope is the differentiation. So we go c minus, we go c plus. That is, just go a bit behind c and go in front of c. So if you are checking at, say, some point c which is in the interval a and b, so c minus and c plus, that is the left hand derivative, we assume it to be, say, c minus h, that is we are going just a bit backward. C plus h, that is we are just moving in front of this c. C can be any value, it is between a and b. You have to check the differentiability at that c. So what we are trying to do that left hand limit, right hand limit. Same way here, left hand derivative, right hand derivative, they ought to be same. There is one line, only single one line. There are no multiple lines. Otherwise, there are multiple lines. That means it is having two slopes. So fc minus h minus fc divided by c, this in place of x, write c minus h minus c. That is, we are replacing x by c minus h. Here we are replacing x by c plus h. So fc plus h minus fc divided by, in place of x, replace it by c plus h minus c. So this as we just indicated in the previous differentiability, limit is x tends to c. Since x is c minus h, the limit will change. It will be h tends to 0. limit h tends to 0, and that's these two has to be equal to similar, that is they are equivalent. If they are equal, that is it is differentiable. If they are not equal, they are not differentiable. That is f dash x exists or f dash c exists, that is differentiability. So there is one tangent, one slope, one line. Any graph, we generally do some two lines, and then we try to make these chords, the points, that the 2 points become one, and that 2 points can become one when we apply the limit, and that if that becomes one line, that is differentiable. This is the question where we have a modulus involved. Show that fx equals mod x minus 2 is continuous but not differentiable at x equals 2. So if the function is continuous, it may be differential, it may not be differential. But if the function is differentiable, the function has to be continuous. Okay? So most of the people, they ask me that you show the answer, so what is the point in solving it? See, answer is always with me. I can just see and write and solve it. The whole idea is that you are going to solve it in your examination. So you need to have a fair idea how are you going to write it. The way you should write it in your exams, the way you write it in your copies. Okay? Now why it is important to show it? Because sometimes some people know the solution. So they would just like to have a look and go ahead rather than listening to all 3 or 4 or 5 minutes of solution. But there are certain people who would like to see also and like to know the logic and reasoning one by one step. So if the answer is between them or in front of them, they will be able to appreciate the solution which I do. Okay, let us start the solution. Now what is the modulus? Modulus x. It just means that it will be equal to x when x is greater than 0 or equal to 0. So this is a number line. We are talking about x equals 0. So mod x will be equal to x. When you go on the left hand side, when x is less than 0, it is going to be negative x, because x will be negative, and negative or negative x will be positive. Right? That is how you get always positive out of the modulus. Modulus always give you a positive value. So how do you get the positive value when x is less than 0? You put a negative in front of it. Negative or negative x is positive. Okay. Now when we have the x minus 2, x plus 1, that means the modulus is same, but now it is not 0. Left and right, we don't have to check at 0, but at say x minus 2 equals 0 is what? X equals 2. So now it has been shifted. It is not, we have to check at x equals 0, but x equals 2. So the same logic, but the point is now shifted to 2 when x minus 2 is 0. If it would have been x plus 1 equals x plus 1 modulus, it would have been x equals minus 1. So above 2 it will be x minus 2 positive, below 2 it will be negative of x minus 2. Same logic. Right hand side it will be plus of x minus 2, left hand side it will be negative of x minus 2. That is minus x plus 2. Okay. So this we are going to use in our solution. I hope you got the idea. Now after this question, mostly we will be solving the differentiability. Because this is the first question, we will also talk about the continuity. That is how you are going to relate, how this continuity is relating or giving rise to the differentiability. Right? Differentiability is nothing but the rate of change. For example, speed is distance by time. So how the distance is changing with respect to time, or at particular point, what is the instantaneous speed at that particular point, that is known by the tangent. The slope of the tangent is given by d by t at that particular instance. That is called the differentiation or the derivative, and if it is possible, it is called differentiability. So we'll start with the continuity in this question. And most of the questions coming will only ask us for the differentiability. But here continuity is also involved. So let us check it. See, x is equal to 2. So we are going to check at x equals 2. So when we go on the left hand limit, when we go on the right, it is going to be right hand limit. So when we go back, there will be some value deducted from 2, so 2 minus h will use. When we go in front, some small value will be added to that 2, so 2 plus h it will be. This h is very small, it is just equal to 0 but not equal to 0. Very small value. So limit, let us apply the limits, and of course what we are going to do, this is limit x tends to, how do we write this? X tends to 2 minus, because we are going on the back side or behind it. In front of it we will use x, limit x tends to 2 plus. So limit x tends to 2 minus, it is fx. So x has to be written as 2 minus h in this case. So when we replace x by 2 minus h, what it will be? So it will be h, limit h tends to 0, replacing x by, because we are going on the back side of x. So what is x less than 2? We have to use minus x plus 2. That is, in minus x plus 2, we have to replace x by 2 minus h. So we are doing it on the left hand limit and right hand limit also. So right hand limit will be saying limit x tends to 2 plus fx. And when we replace this x by 2 plus h in x minus 2, it is going to be limit h tends to 0. Okay. So x greater than or equal to 2, x less than 2, this is how we are going to use it. But we know when we have x equals 2 minus h, we are going to use x less than 2, which is negative x plus 2, replace 2 minus h in place of x in negative x plus 2. That I already explained it to you. So this is going to be limit h tends to 0, and we have minus x plus 2. So in place of minus x plus 2, x replaced by 2 minus h. Minus x is 2 minus h plus 2. And here we have limit h tends to 0. So now we are going greater than 2, and for that we have to use x minus 2. So in x minus 2, replace x by 2 plus h. So 2 plus h minus 2. Okay. Now what you are going to get is minus 2 plus h plus 2, and here you have 2 to get cancelled, h, here also you get 2 to cancel, you get a h. So both ways you get limit h tends to 0, h. When you apply the limit, it is going to be 0, okay. So LHL and RHL, they are both equal. That means the continuity is there. It is continuous. This function is continuous. Okay. This is continuity. This is the first step. Now we have to check for the differentiability. So if the function is not continuous, it may be differentiable, it may not be differentiable. Okay, this will remain. What I told you in the earlier discussion. Mod x minus 2 is the opening of this is independent of other things. Mod x minus 2 is x minus 2 when x is greater than or equal to 2. Mod x minus 2 is minus x plus 2 when x is less than 2. So we are coming to actual differentiability now. So the discussion point of this whole exercise is differentiability. Okay. So x equals to, this is differentiability. So I'm writing it short, dy. So left hand derivative we are going to find out. Right hand derivative we are going to find out. LHD and RHD. Same curve, it can be any curve. At point 2 we have to check, so we have to go just a bit behind, just a bit front. That is some value h. So the first principle we are going to use, first principle. Okay. So this limit x tends to 2 minus, limit x tends to 2 plus. Okay. 2 minus and 2 plus. So this we are going to say f x minus fc divided by x minus c. Since c is 2 here, we have fx minus f2 divided by x minus 2. Okay. And then we have fx minus f2 by x minus 2, same way, in limit x tends to 2 plus. So x we are going to replace on the left hand derivative by the same way we have done in the, you don't have to do this 2 minus h here, you can do it. I'll show it in your next question. So next question you will see that I am going to put this x as 2 minus h or whichever constant is there. But here it's simply minus x plus 2 you write, because you know what is the value when x is less than 2. f2 is you can directly get the value f2, just put it here. So 2 minus 2 is 0, mod 0 is what? It's going to be 0. fx, this is mod 2 minus 2, that is mod 0. And then you have this mod 0 is what? It is going to be 2 minus 2, 0. Mod 0 is 0 only. So in both left hand derivative and right hand derivative, I am going to put f2 as 0. So minus x plus 2 minus 0 divided by x minus 2 here. Here we have again same thing, fx in place of fx, because you are going just a bit ahead of 2 plus something. So you have to use x minus 2 here. So x minus 2 and minus, of course f2 was 0 as I just told you. Then x minus 2 in the division. So you have minus x plus 2 divided by x minus 2. And in the numerator you can just take negative constant. So you get x minus 2 in the inside the brackets. You can cancel these two, you will get a negative 1. On right hand derivative, it is going to be 1. X minus 2 gets cancelled with x minus 2. So limit x tends to 2 minus limit x tends to 2 plus, both the cases. So no, see, please remember, when we replace this 2 minus by minus x plus 2, the limit also changes. It will be simply limit x tends to 2. When we replace fx by x minus 2, the limit is not 2 plus then. It will be simply limit x tends to 2. So you get a negative 1 and 1. That means you have a LHD and RHD, they both are not equal. When we put 2 minus h and 2 plus h, it is going to be, again, you'll find it that it will be not equal to 0. So since the left hand derivative and right hand derivative are not coming equal, the left hand limit and right hand limit were equal, they were 0. But the left hand derivative and right hand derivative, they are not coming equal, they are negative 1 and 1. So fx is not differentiable at x equals 2. Show that fx equals x raised to the power 1 by 3 is not differentiable at x equals 0. So x raised 1 by 3 is nothing but third root of x. Okay. So this is not differentiable at x equals 0. So what do we do here? You have to go, if you want to go to continuity, you can go to continuity, show that it is continuous or not continuous, it's up to you. But the question is simply asking about the differentiability. So we will be checking about the differentiability here. Right? And here we are going to use that 0 minus h and 0 plus h. Same way we were doing it in the continuity theory. Same way we are going a bit left, bit right of 0, because the point of contention of checking the differentiability is x equals 0. So here we have a 0. This is x equals 0 minus h. This is x equals 0 plus h. This is what we are going to put. Limit x tends to 0 minus. Here limit x tends to 0 plus, because at 0 we have to check or find out the differentiability. Fx minus fc by x minus c. In place of c, the x is given as 0. So it will be fx minus f0 divided by x minus 0. I'll write it as x only. Here fx minus f0 divided by x minus c. C is of course 0, so it will be only x. Okay. Now this left hand derivative and right hand derivative, fx is what? Fx, you just replace it by 0 minus h. On right hand derivative, replace it by 0 plus h. So limit will change. Limit h tends to 0, it will be fx, just put x as 0 minus h. So it will be f in place of 0 minus h. It's just minus h only. 0 plus h is simply h. Okay. So fx What is this? Third root of x. So when we replace this f minus h, it will be third root of negative h. And negative h to the power 1 by 3 it is eventually. So I am writing it directly. So minus h to the power 1 by 3 minus f0 is what? Third root of 0, any root of 0 is going to be 0 only. Third root of 0 is 0 only. So just write 0. And in place of x, write minus h. So this is minus h to the power 1 by 3 divided by minus h. Now just minus h you can take in the numerator because it is limit h tends to 0. So this you have to write everywhere. That's why I am showing you the solution on the left hand side. When it goes up, it is going to be negative h to the power minus 1. So the power is going to be added because x to the power a into x to the power b is x to the power a plus b. X a x b is x a plus b. Okay. So 1 by 3 plus minus 1 is going to be negative 2 by 3. I hope you got the idea. The power add if the base is same. So 1 by 3 minus 1 is going to be 1 minus 3 by 2, that is going to be negative 2 by 3. So minus h to the power minus 2 by 3, limit h tends to 0. Now whatever h can be, h is 0. Okay, whatever is the power, it doesn't matter, it is going to be 0 only. I hope you got the idea. Okay. Then my h to the power 1 by 3. Again h to the power 3 and f0 is 0 only. And x is h only. Right. So either this h, if you can take on the left hand side, I am saying if you take minus 1 to the power minus 2 by 3 into h to the power minus 2 by 3, then also it is going to be 0 because one term is 0. When you have any term, when you multiply multiple things and one of the term is 0, it is going to be 0 eventually. So here we have h to the power 1 by 3 and h to the power 1 in the denominator. Same way when we did in the left hand side, this h to the power 1 by 3 divided by h to the power 1 goes up. So it will be h to the power of minus 1. So h to the power 1 by 3 into h to the power minus 1. 1 by 3 and negative 1 gets added. It is going to be h to the power minus 2 by 3. Again, whatever you do with h doesn't matter because it is going to be 0. H tends to 0. Anything to the power 0 is going to be 0 only. So you have a 0 on left hand derivative and right hand derivative and they are not equal. When they are not equal, that means this x raised 1 by 3 is not differentiable at x equals to 0. So this question, I don't know, in our perspective, in our solution it is not coming as equal, so it is not differentiable. The question is saying show that it is not differentiable at x equals to 0. In our case, both are coming 0, so it may be differentiable. We don't know, but as the answer goes, as the solution goes, it is differentiable, right? Okay, this question we are going to take in the next discussion. Till then, thank you so much and take care of yourself.